Alright, so got off of work and let's continue our Leetcode Neatcode journey. So I think I am going to do a little bit more of the linked list and we'll see how it goes. So let's just do add two numbers. Okay, let's try it. You are given two empty linked lists, L1 and L2, so they're empty, okay? Or non-empty, sorry, where each represents a non-negative number, okay? The digits are stored in reverse order. The number is 321 represents 1, 2, 3 in the linked list, okay? Each of the nodes contains a single digit. You may assume the numbers do not contain any leading zeros except the number 0 itself, okay? Return the sum of the two numbers as a linked list, okay? So 1, 2, 3, and we want to have so 1 here, so 1, 4, 5, 2, 5, 7, and then are we doing carries as well? That one will probably be something that we need to keep in mind. Okay, so the way that I'm thinking about this is I will reverse the linked list, okay, and I'll grab this number, and then each time I go, I will add 10 to it, essentially, or multiply by 10, right? So I'll have some running number, which is like 10, or like the previous base, and then add that to my total. Okay, so something like total 1 is equal to 0. Current base is equal to 1, okay, because it's the 1th place. And then I'm going to have total 2 is also equal to 0, and I'm going to sum, I'm going to keep summing, right? And then I can do, like, once I sum these two numbers together, then I can keep doing the modulo operator on it. Okay, that's what I think I'm going to do. So let's try to reverse it. So reverse linked list 1. Okay, then I'm going to have to do reverse linked list 2. Okay, and then sum the numbers. Whoa, okay. Sum the numbers and then create a linked list from the modulo of the sum. Okay, and we're gonna have to make sure that we get the top node. Either we reverse the linked list and then we have to reverse it again, the final one, or I can just do the modulo of the highest base of it. Okay. Okay, so let's come in here and let's try to do this. Okay, so I am going to say while current, right? And so that implies that we need a current is equal to L1, okay? Future is equal to current.next, okay? Now I want to say previous, so we need a previous, right? Yes, we do. Okay, so we need a previous. Let's put that on there. Okay, so dummy 1 is equal to node, like this. Okay, do I need to initialize it? I'm not sure. We'll see if we get an error. Okay, so previous, now I need to set previous, so previous is equal to dummy1, okay? So now I want to swap them, right? So, wait, hold on. So I think, actually, I don't want dummy. I think I want something kind of like this. So previous is equal to none, right? And now I want to say current.next is equal to previous, right? And now, okay, so my current.next is now equal to previous, got it. And I'm here, so now I want to go to the next one. So now I want to say current is equal to future. Yeah. Future, right? So then I go to the next one, and I want to set previous though. Okay, so I want to set previous, right? I think that is a yes. So I'm going to say previous is equal to current. Yeah, I think it's like this. Okay, so we reversed the list here, and now I need to traverse it and actually grab them. Okay, so I'm going to say grab numbers from linked list 1, right? So what I'm going to do is I'm going to say current is equal to this previous here. Previous, okay. And now I do the exact same thing. Or not exact same thing, but I traverse is what I mean. While current. Okay, so I'm going to be using that total 1 and right here, and then current base here. Okay. 1 and current base 2 is equal to 1. Okay. So I'm going to come in here and what do I want to say? So I'm starting here, right? So I want to do my total plus equals, yeah, so total plus equals, come on now, there we go, current dot value, okay, but multiplied by this current base 1, okay? Then what I want to do is I want to increase that. I want to say current base 1 multiply equal 10, right? Because I want to multiply it up to 10 now, and each time we go to a next node, that's a base of 10 higher. Okay. So now what I want to do is go to the next one. So current is equal to current.next, like that. Okay, I think that's kind of good. Let's do the exact same thing. So I'm going to say current is equal to L2, and then I'm going to say while current, right? And I'm trying not, hold on, let me come here. Because I'm trying to get practice, right? So I don't want to be looking up there. So I'm trying to, let's do it twice. Let's practice reversing a linked list twice. Let's get good at it, okay? So, okay, I also know that I need a previous, right? Previous is equal to none, because I want it to go back to that none there. And now we should be able to walk through this, right? So I'm going to say current. I want to capture the future node. So future is equal to current.next, like that, okay? And then what I want to do is I want to change my pointer. So current.next is equal to previous, right? Yes. And then I want to say previous is equal to current. Previous is equal to current, and current is equal to future, like that. Then I want to add up the numbers again, so add up the numbers, okay? So current is equal to that previous, because that current walks off the edge, and now previous is going to be pointing to the last node, which is now the head of the new linked list. Okay, so add up the numbers. Good, good, good. So I need to, while current, I need to say, I want to add, so total 2 plus equals current.val multiplied by current base 2, okay? Current base 2 needs to be multiplied equal by 10, okay? And now I want to go to the next one. Okay. So now let's see if they match, right? Just cursory glance at first. Future, current. So either I got them both wrong twice, which definitely is a possibility, right? Or I understand the concept. So one of the two. I don't know which one until we figure that out, right? Until we submit it. But either I understand the concept of reversing a linked list, or I understand it very incorrectly because I did it twice. Okay, so this one is here, here, here. Okay, those are the same as well. So now sum the numbers. So total is equal to total 1 plus total 2, like that, okay? Now we want to come in here and we want to create a linked list from the modulo of that sum. Okay, so now what I want to do, this one I do want the dummy. Dummy is equal to node, like this, okay? Current is equal to dummy, while true. Okay. So now what I want to do is I want to keep going until I finish all of the numbers in total. So new node is equal to node with, I'm just going to say it like this, and I kind of want to break it out. So new node dot val is equal to, it is going to be equal to total, right? But I want to get, I want to grab because if I do the modulo, it's going to give me, I can keep like popping off this last value, but that's going to be building it from the back, which is not what I want. Return the sum of two numbers as a linked list. Okay, yeah. Although they have 579 right there. Hold on. 5 is the head? Eight, 1, 81. 579. 18. So in the test cases, it kind of looks like we are returning. Hold on, but this one, yeah, 5. Wait, 3, 6. Hold on, this is from the 321. 321. I was assuming that this was 123, and that this one was 456. Okay, my assumptions were wrong. Well, it looks like I am going to comment out the reversing. Okay. Oh, and that would have had to been L2 as well, though. Okay. Get rid of that for clarity. And now I'm just going to... That's unfortunate. That seems like a little bit less interesting of a problem. So I'm going to say current is equal to L1, right? And for this one, current is equal to L2, like that. And then we keep going, but we still do this, right? And then we sum them, and then we come here, and now I want to say total, like, value is equal to total modulo 10, and then I say total equals total integer division by 10. I think that will work. Okay, so is equal to this value. Okay. So now this one is going to be while total. Okay. And so I'm creating this new node, and now I want to have current dot next is equal to new node. Okay, and then I want to say current is equal to new node, like this. And then return dummy.next. So this is going to grab the lowest number and place it at the head, and then do it like this. Let's see if it's right. Let's just press run, see if we got anything wrong. Current, where it is. Okay, why are you angry? While current. Yeah, I would be angry too. Okay. Let's see if we got our algorithm right. Okay. So local. Yep, you are Python, so you need non-local. Total. Non-local current base 1. This is going to be annoying. And I think you are total 1, right? Yeah. Total 1. Current base 1. No. Okay. This is an integer, and this is an integer, so those are the things that we need to worry about. This one we are going to have, so value, I declared it there, that's fine. Total, and we don't use the base. Okay. Should be like that, let's see. Okay. So why are you angry? Is assigned before non-local declaration? No, it's not. Did I misspell something? I don't think so. Alright, so we're going to go to Gemini and not waste our time looking at things like that. Okay, so what are they doing? Add to no, what? Okay, no, just tell me how to do it my way. Okay, I don't have internet, so awesome. Okay. Happens almost every video. My internet always, it goes out all the time. Okay. So and then convert them back. It has a few pitfalls in coding interview context. Integer overflow, Python I don't care. Efficiency, traversing the list. As of right now, I can't think of any other way to solve it. So if I get a slightly less efficient algorithm, but it works, I'm okay with it. Notice the problem says digits are stored in reverse order already. That's actually a huge gift. Yeah, it means that the ones place is the first node and the tens place is the second. Yeah. Oh, we're probably just going to do like 2 passes or something. Yeah, I see. Carry. Okay. I think I see. I'm not going to look too... Oh, come on. Do I still not have internet? Okay, I do have it. I do have internet. To make it work in Python, we need to clean up a few things. Python is actually the only language where it's a viable strategy. Well, good thing I'm using Python, right? It supports arbitrarily large integers. Good. The non-local and node errors. Yeah, let's figure out what's going on here. You need non-local to modify a variable inside of a standard while loop. You only need that for nested functions. Wait. No, nested functions. So, this one is fine? Wait, wasn't it just complaining? Hold on. I thought it was just complaining. Total. Interesting. Okay. So it's upset about total. Final sum is greater than 0. Let's just try that. Well, total is greater than 0. Does this make you happy? No? But we're guaranteed that they're non-empty, right? Sure, I can do it. If total is equal to 0, return node with what? I don't know. I don't know. 0 and none? Sure. 0 and none. Okay. But this is still wrong. It's still upset at me. So digit is here. Okay, let's copy and paste back into here. Oh, okay, whatever. Total, since total isn't defined yet, this will crash. Yeah, I don't understand this one. To add total 1, but your code says total 1. Hold on. And then it was also unhappy about this. Is it not called node? List node, okay. Let's run it and see what the error says. That way we see the error. Okay. What does it say? Name node not defined. Okay, good. So, like this, list node. Yep. List node. Okay, And submit this and see if it works. No. List node. Okay. There we go. Awesome. So we did this way. Let me... I want to verify... This is the correct way to reverse the list, right? Okay, let's make sure that we have that. You nailed it. Awesome. There we go. So now I'm going to come back here and let's do the other method. Alright, so we're going to come here and we're going to try the other method. So now that I got a little bit of a peek into what that second method will look like, let's do that. So now with the updated information, I'm going to come here and if these are the base, then we can just add those. I was assuming that this was like the hundreds place, and it was like 123, kind of like that, and so I couldn't just go through them because maybe this one was 23 and this one was 4 million and like whatever, right? Like 4,560,000, kind of like this, and had a whole bunch more out here. Okay. So, what do I want to do? I want to essentially do it in place, right? So, dummy is equal to list node. Yes, it is. Okay. Current is equal to dummy. Now I can just do it from L1 and L2. So I'm going to say while again, it does not say that they are the same size, though. Well, then in that case, we would need to just append the next one, because it doesn't say that they are the same size, right? So this one could be, there could be a 4 out here, and that way it would be 400 or 4,321, and then this one just be, oh, this is 654, kind of like that. So what I'm going to say is I am going to say while L1 and L2 no, I want to say ors, right? Or L2 or that carry, like this. And carry is not defined yet, that's fine. If L1, okay, get it and move to the next, okay? If L2, once again, get it and move to the next, okay? Then add the numbers and create the new node, okay? So I want sum number 1 is equal to 0 and sum number 2 is equal to 0, like this, right? So if L1, what do we do? I want to do S1 is equal to L1 dot val, and then I want to move to the next one. L1 is equal to L1 dot next. Okay, L2. S2 is equal to L2 dot val, and then move L2 is equal to L2 dot next, like this. Now I sum them. So digit, right? Or I guess maybe I can say num is equal to S1 plus S2. Okay. By the way, I am going to define this carry is equal to 0. Okay. So now I want to say carry is equal to this num integer division by 10, and then I want to say digit is equal to num, where's my modulo? Come on. Come on. There it is. Modulo 10. So new node is going to be equal to list node with the value of, I'm just going to break it out actually. I like to do this. It makes me feel better. New node dot value is equal to digit. Okay. It's equal to digit. And now I want to current dot next is equal to new node. Okay. And now current is equal to that new node, or I can just say current dot next because I just assigned it. Okay. And then return dummy dot next. Ooh, let's see if it works. Oh man. Oh, plus the carry. The previous carry. Yes. Yes. 对，就是这样了。That's how we do it. Okay, cool. Awesome. So, thank you guys for watching this video. If you liked it, subscribe. I would love to have you around, and we'll keep on practicing Leetcode, keep moving forward, keep doing our engineering projects, and yeah, so if that's interesting, subscribe, and thanks for watching. My name is Timothy Lee Grant. I'll see you guys in the next video. All right.